Homework 12, a big mix of questions that people have struggled with and things that we need to practice. So first off, we start with graphics calculation. So hopefully that's going to be straightforward enough, but I've tried to make it a little more difficult by adding in the extra part about the 1 GB flash drive. So just remember, if we've got 600 pixels by 400 pixels, that is going to give us the area in pixels, which we then need to multiply by the colour depth, which hopefully you can spot in here is true colour, which equals 24 bits per pixel. And that's going to work out the file size of one image in bits, multiplying all these numbers together. So it would be useful to maybe get it into gigabytes, or what would be a better job, or a better idea, sorry, would be to convert the number of gigabytes into the same unit that you work out the image for. Question 2 is about 2's complement. Now remember the process that we go through for 2's complement. 2 is 64, 1, 2, 8. Now remember that you write down the number as it is, just normally, so this is positive 2. In order for us to get negative 2, we then invert the number. Excuse me. Invert the number, and then we add 1 on in order to convert it. So 1 plus 1 is 2. 2 in binary is 1, 0 with the carryover. 0 and 1 is 1. And after you've done that, hopefully you can remember that they'll carry on like so. Now this is the representation for negative 2 and 2's complement. And remember, the cheat that you can use is to double check your answer and have the first part as a negative. So if you carry out that addition, hopefully you'll work out. Hopefully if you do the correct process first and then use the cheat to double check your answers, to check you've got the correct answer, yes, really. Next one about digital cameras, advantages and disadvantages of compression. So things we could mention are lossless and lossy. We should really define what compression is in this answer as well. So not majorly necessary to talk about what lossy and lossless are here, because it's more just about compression. So make sure we define compression in our answers. And some of the advantages: smaller file size. Now speed is something that people always mention here. Incorrect. Upload and download speeds are not faster. It's the download and upload times which are faster, obviously because the file size is smaller. And that would work for this question for transferring the file from the digital camera onto its storage medium, and also for transferring it to a computer system afterwards. Disadvantage of compression, can talk about how if it uses lossy compression, remember that reduces the quality of the file size to reduce the file. Compression of images could take a long time for much larger files, but the trade-off is they take up less space, but we can fit more images into that space. Next question is about interpreters and compilers. Now hopefully we can remember that interpreters are good for debugging, and that is because they translate and execute each line at a time. Now this question here specifically says which interpreter is faster at translating the above code. I've got to describe that here too, in terms of why it's faster. Now if you think about an interpreter and a compiler, hopefully you know that a compiler just translates the full program at once, doesn't stop for any errors, and the errors are returned as an error list, whereas the interpreter translates and executes each line in turn. Now that while loop in an interpreter would actually be executed 9 times, because or is it 8? You can work out the number from the loops for me. Every time the loop repeats with an interpreter, it checks if it should execute again. So that while statement, the second line of code there, is actually translated the same number of times that the loop actually executes for. So it's actually pretty inefficient when it comes to translating the loops. That's an important question. The compiler translates the code once, whereas the interpreter translates that loop every time it's going to. Question 5, how do we make our code readable, and why should we make it more readable? Well, we want to make it more readable because we work in teams, usually in real life programming, and we want to make our code easier for other users to understand in order for them to edit it, update it and maintain it. Now, some of the things that we can do to make our code more readable: indentation, which happens automatically in Python really, blank lines, just improve the readability because it breaks up sections of code, good variable names, because then they explain really what the program, or sorry, what the variable's been used for. And another one is modular code, that separates up larger chunks of code into separate, smaller areas, which make them more easy to maintain, easier to read, and it makes your main program much smaller. Difference between ASCII and Unicode: hopefully remember that one is 7 or 8-bit, one of them uses 16-bit. Hopefully remember that one of them obviously uses less memory per character, one of them uses more memory per character, but one of them is capable of representing more languages because it's got a larger character set. And hopefully remember that the first number of characters in ASCII from the Caesar cipher algorithm work we've been doing is the exact same in both, and that's how we can convert between them. Is a tricky one. Okay, this is one we always struggle with. If we have this sound appearing here, which is an analog signal that's constantly changing, obviously we can't have this representation recreated in a computer system. We need something digital. So what we have is a sampling rate, and we also have the sampling depth, which is how often a sample is taken. So sampling rate, how often a sample is taken of the original sound, and the depth is similar to the colour depth, is the number of bits that we can have to recreate the sound. So what would happen is every time there's a sample taken, it would store these at the particular points. And remember, we did this activity in class where it never quite recreates it, and what we would actually end up are these sort of digital representation of the sound. So how is sound represented in a computer system? Well, the sampling rate determines how often that there's a digital sample of the original sound taken, and the depth determines how much data to store about it. Now that's a really important thing that you should definitely read and brush up on. We've got to have really good. And the last question: steps in a fetch execute cycle. So we know there's 4 steps. Hopefully decode and execute. Hopefully we can remember that that's the 5th step, and hopefully we know that the first 4 steps are what are a read operation. Hopefully remember the first one, MAR, which is the memory address register, is given the address to access by the control unit. After that we're ready to go, and the read line is activated. After that, the data is released onto the data bus, and it's transferred via the data bus to the memory data register. Now that I've written there is not enough to get you all the marks for that question. That's just the outline. So let's go and fully describe each of those steps as best you can when you're answering that question.